Hello everyone and welcome back to this new video of the Agentic AI series. In this video we will continue with the core components and we are moving to the reasoning engine, and that will transform us from prompts to building runtime systems. As we have seen in previous videos, we were talking about agents, agency, and the architectures, the design patterns, and so on. In the last one, we have talked about the intent understanding and what it means in agentic AI and so on. But today we are crossing a little boundary here, which is important for us. We stop where talking about conceptual elements, and we are starting to talk more about engineered elements. We are talking about real agents that we will be building together throughout the video and the upcoming ones. So today we are not talking about prompts, we are not talking about tricks. We are going to build a real reasoning engine as a runtime system from scratch. So by the end of the video, we will be able to understand why the LLM is not a reasoning engine and what is the difference between the reasoning engine and the LLM itself. What actually makes the agent. So we'll see the internal composition of the agent in reality, and how to implement that agent actually as a reasoning loop using LangChain, LangGraph, and such frameworks. So let's start with this strong claim here. The large language model, the LLM, is not the reasoning engine, and it only predicts tokens. It doesn't reason at all. Um, what we call reasoning in agentic system is actually the control loop, the whole loop that we usually define, starting from observing a state, deciding what to do next through iterations, acting in real world environment with tools, and update the state, and then to repeat until a stop conditions is met or hit, and that where we end our loop and we achieve the objective of the agent. That loop in total, it's all components that are related to it, including the LLM, is what we call the reasoning engine rather than the model itself. LangChain, LangGraph are very useful for this, to implement easy and simple reasoning engines that we can go through, but powerful ones at the same time. So, what we have here, we know that we just said that the reasoning engine is not a chatbot, it's not the LLM, and it requires an explicit state, an explicit or explicit tools, explicit control flow, and explicit termination. All of these elements, they achieve the loop that we see in the diagram on the right, with the LLM as a model at the heart of it, as a brain, and then the other steps are conducted around it. Because the agent must act, we need tools, and the tools are the contract between the agent and the real world environment. And those tools, they should be well defined with their inputs and outputs, because they are the contracts. And that's where the schema of the tool makes sense and comes as an important part. And here we see that that connection between the agent and its brain and the outside world, between let's say the body with its hands towards the words, we can see how the agent is able to interact with the world in a well-defined manner. Because otherwise, the reasoning without action, or the agent without action, is just a text. There's nothing happening beyond that. State is the real memory in this agentic loop, and it's where our reasoning live actually. And so we need to have a place where we record what happened, why it happened, and then to connect to what will happen next. So reasoning, as we said, um, is not in the model. It happens in general between the state as a memory, between the transition between different states, between the policies, etc. So if we don't have a state, the agency diminishes. We don't have agency at all. The model itself in this reasoning loop acts as the policy function. So it only decides what next action to be taken. It doesn't decide to loop. It doesn't decide to stop. It doesn't decide to execute tools. It just says what is the next action to happen. Uh, Other elements, they happen outside the model itself. And here we come to the whole cycle: reason, act, and observe. And we need to split here the tools execution from the decision of what next step to happen, because this will provide us with better observability and on how tools are being called, with what input, with what output, and how we are able to track and trace errors and exceptions if they happen throughout the whole reasoning cycle. And with all together happening, we really need to pause for a moment as an agent and reflect on what happened. And that doesn't happen by just thinking harder. We should have explicit rubrics. We should have explicit boundaries for retries, as to set a number for how many times we can retry an action. We should have very well defined and deterministic termination state where where we should stop the agent loop in general. And that reflection node or component will help the agent or enables the agent to achieve this part of the cycle. Then finally, the agent must terminate. No agent can continue infinitely. And that's where we have the max steps that can be taken, max retries, budget limits, quality threshold, etc. Because without these kind of termination conditions, our agent is just a loop, an infinite loop actually, with a credit card where resources are being consumed without any control. And we don't want an agent to be like that. So far we been talking about this reasoning loop in theory as different components, as we have seen, but let's move now to see it in reality in a notebook where I built a simple notebook here in Google Colab with all of these elements together, so that we can see how this reasoning engine is being built using LangChain and LangGraph. First of all, we are installing some libraries that we need for this environment, and then we need our OpenAI API key. I did the installation before, so I'm not doing it again. Then let's start with importing the OpenAI key from my environment secrets. I have my keys stored here and enabled for this notebook. Then we move to some imports from LangChain, LangGraph, and some supporting libraries, and so on. Let's do the imports. The first step where our definitions start here in the loop, I'm starting here in the coding with the tools. We are building a triage agent and a reasoning loop that is related to that. So we have two tools. One is search in documents, which I use a small in-memory corpus for that, and then a tool calculator. And here we are using structured tool, unlike what we have used in one of the demos and tutorials that we have built in previous videos, where we used the decoration add tool from LangChain. But now we are using a different way to define the tools. As see here, first we define the purpose, and then we define our search input as a well-defined input or structured input, and then our tool search docs. It goes in the corpus, and it invokes or does the search in the tool in the documents and returns the results. Then our calculator, again with the input for the calculator, certain allowed characters, and we define our calculator as a tool, and we map the tools with this list. Let's execute here, and then we will define the agent state. We start the agent state will contain messages, so the list of messages that we have as a memory, and then the steps and max steps counted so far, and max steps where it's the stop condition, attempts and max attempts, same thing, and the last tool call result as well, and the termination flag. And we execute, all looking good. Then we start with the model setup. We make model from chat OpenAI, and we have here two variables. One is the model, which is from make model, and then we bind with model with tools. We bind the tools to the model, so it can call the tools. And now we start with our first reasoning step here with the model node. So it starts with a system prompt that it is an incident triage assistant. It's been asked to be concise. If it needs to call tools, it will go before it starts guessing, and to go through the search docs tool to read from the run books for guidance before guessing. And this model node, it just append actually the last message to the messages with the system message, the initial one, and it retains the state. So nothing more here. It invokes, of course, with the model with the messages, and then it will decide what will happen next. And here we come to the tool executor, which is the act part of it. And here we start with our tools node, and based on the state, we decide what tool we have to call, and if we are calling a tool, we decide then the tool that we are calling and what arguments, and then we have some validation on the inputs if the inputs are not well structured, and then we have some validation on the exception if it's failed, and then we have the tool result, and we format the tool result with the tool call ID as a JSON, and we append it to the system, to the agent state. Let's call it here. Then we have the reflection part, and here we define our critic node, the reflect prompt. The rubric is to use the tools before guessing, actionable steps, no unsupported claims, being concise, and so on. And in the reflection node, we have the critic request, critique this answer. We take the last AI content and we return with JSON with verdict, issues, and improved answer. And then we validate here. We look if the verdict passed, then the state is done, and that will exit the agent. Otherwise, we will increase the attempts, and then we go. If we reach to the max attempts, it means that we have to exit as well. We say the state is done, and if a revision is needed, we ask to revise the answer with another with the revision instruction, and we add it to the state messages. Let's run it. Finally, here we have the stop conditions and routing. So should go to tools, should stop. We define the functions for this, and the router itself. So the router, it says if the steps more than max steps, it ends. If it should go to tools, return tools. If it's it needs to reflect, go to reflect, and return to model node. we have to build our LangGraph app here, and then we add the nodes, model, tools, and reflect. The entry point is the model, and from the model we have conditional edges. We go either to tools or to reflect or to the model itself or to end. And then from tools we go to model. After tools we have to go to model, and after reflect router. So if the after reflect, if the state is done or the state steps is more than the max steps, we go to end, or otherwise we go to model, and then we add this conditional edge between reflect and the model as using the reflect router after reflect router. Let's run this node as well, and here we will do a test of our model, and we will see here we are asking a question. We are seeing loss of 503 after a deploy. What should I check first, and what are the likely causes? Let's see what it gives us. So it says it had two steps, 0 attempts. Let's try to print this with a trace, and the show trace will allow us to understand what happened within the reasoning loop. So the human said this, then the AI tool call said searching docs. The query is 503 error after deploy causes and checks. The tool output is this, and then the AI produced this final message here. And this was the likely causes for the issue, etc. And it tells us to go it provided us with the final message here, and this is something where we ended our reasoning, because the answer was good enough to end the reasoning loop on it. Another example here, to use the calculator. Let's see it. We're computing a simple math expression. So the computing here is happening based on the human prompt. The AI is calling a tool called calc, and then the tool is doing the AI is doing the computation based on the parentheses, the multiplication, division, etc., and so on, and the final result is 4. So this is coming as well within like 0 attempts and 2 steps and so on. But if we look back to our reflection node, for example, here, this is a graph in the reflection node. So no, still okay. Here we said if the critic verdict equal to pass, then the state is done. If we remove this statement here, so we don't update the state and we return state, it will make the agent to reason again and again, or loop again and again until it reaches the max attempts. Let's run it like this and retry our demo. Let's go to the calculator, for example, or let's start with the run, and we'll see the difference now. It's taking longer for sure because it's reasoning more now and going in the loop, because there's no end condition based on the answer itself, which was what we removed. I think we've missed something in the run here. We need to rebuild our so this is the one. Let's run it and run other tools. And as we see here, we now it finished, and it took like long time to finish the execution, and the number of steps is 12. Let's see what happened in these 12 steps by showing the trace. As we see here, it's so easy to read it: human, AI tool call, and then the tool output, and then the AI message in these four stages here, as we see. Let's retry and see now what happened in our code. So here, what happened exactly? So we start with the human AI tool call, and then the tool produces a result, and the AI provide us with the output. And then we come back again with the same loop: the AI tool call, the tool output, the AI, and then here we have the summary, and then it goes with the same answer again and again, because we are asking it to revise, and it's producing the same answer until it reached to the max steps that are allowed. And that's where the termination condition is really crucial. Otherwise it will go infinitely in this loop. Same thing, let's try with the calculator, for example. Execution is taking long again because it has to reach to the maximum number of steps before it terminates the loop. Here we go. We see the computation happening again and again, providing the same answer, but because we don't have a termination condition on the good answers, the termination happened only on the number of steps, the max steps that we are reaching with this. So in let's say in simple words, we have implemented the reasoning loop completely from the very beginning. We define our model, that is the brain of the reasoning loop, and then the what to decide next, and how to execute the tools, I mean acting, and then what are the reflection part of it, and what are the termination conditions that will end our loop. So basically, in this notebook, we have implemented the reasoning engine as a graph with nodes, state, and routing. The model is the policy-driven decision function, not the whole system, it's just part of it. The tools are the capabilities, and the schemas are the reliability on the communication between the model and the outside world, or the tools themselves. Then the reflection part turns the quality control into an engineering loop instead of being just prompting. And then the stop conditions prevent infinite loop, and for sure it gives us cost control as well. That's all for today's video on the reasoning engine, and I see you in the next one.